Hi students, welcome to Vedantu J English. I'm Diksha Ma'am, your chemistry master teacher. So everybody let me know in the chat box if I'm clearly visible and audible to all of you or not. Yes students, so today we are going to start with a new chapter of class 12 for your JEE 2026, that is chemical kinetics, right? So this is one of the most, I would say, easy chapter, right? Reason being because predictable questions are asked. It's not so difficult. The direct formula based questions are asked, and even the concepts are interesting here, right? So you will not feel like, okay, I can assure you, I can guarantee that if you study this chapter, especially solution chapter, chemical kinetics, these two chapters are something which will definitely for sure will not ditch you in the exam, right? They will definitely, you will score good marks from these two chapters, right? Okay, so everybody, shall we start the class? Very good evening. Very good evening, students. Very good evening. So, dinner, ma'am. Dinner time. That's why I gave you dinner time, 8:30. That's why I started at 8:30. I thought that students always are like in the chat box, ma'am, we didn't have our dinner, right? So that's why I thought that why not to start a class at 8:30 so that you can also have your dinner, and after that with full energy you can start your class, right? Okay. Yes, students, shall I? Okay. So, everyone, let us start this. First thing is, right, how many of you, right, love this chapter? How many of you hate this chapter, right? And also let me know in the chat box, how many of you have actually completed full solution chapter on this channel? How many of you? Because I have seen that you guys don't do your homework here. Only two people, only two students, Unhuman and Shailesh. That's only. Two students have done their homework. That's it. Why so? Why it is like that? Why you're not doing your homework, right? So what's the benefit then if you're not doing your homework? That's why today I'll send the answers on the Telegram channel, right? The answer of the solution chapter that I gave you homework, I'll send that on the Telegram channel today itself or maybe tomorrow, right? You can verify that. But I will solve the answers when at least 10 students should do their homework, right? Less than that, I'll not solve the solutions in front of you on this channel in the video format, right? I'll just give you the answer, right? If you are interested, if you're not interested in putting the efforts, I will also not put. But if you are interested in putting the effort, then I assure you, I will not just show you like, okay, I'm not there for you. I'll be there for you if you are also putting your efforts, right? Okay. So in this chapter, I want everyone, we are starting with chemical kinetics, right? Daily I am going to give you homework, right? I want every student to do their homework, to ask the question if they have any query in the comment section, right? Okay. Yes. Hello to everyone new here. Let me introduce myself. I am Diksha Kaushal. I am BSc MSc in Chemistry and BEd, and I have 8+ years of experience in teaching students chemistry, and that's why I want all of you to have that interest in chemistry. I want all of you to actually do their homework so that I can also provide you with the DPPs in there. I already have DPP ready for solution chapter, but that I will provide only when I see in all the solution chapter videos you do your homework. Only then I'll provide that. Right? Otherwise, it's not, everything is not free. Some things are not even, you can't even purchase them, buy them with the help, with the money. Some things are only you can buy them with efforts, with hard work, right? And with consistency, right? Okay, yes. Ma'am, Telegram channel name. Okay, so I'll just give you the Telegram channel. So this is, guys, our official Telegram channel, right? You can just scan this code and you will land up to the official Telegram channel of Vedantu J English. There I'll send you the homework, right? Okay, the answer for the homework, right? Now, let me just see and let's just start the session starting with what exactly is a chemical reaction, right? Chemical reaction, some two reactants will take part, they will form the products. Now, if we talk about, we have physical chemistry chapters dealing with the reactions only, right? In thermodynamics, we deal with feasibility of the reaction. Gibbs free enthalpy. We talk about entropy, right? All these things we talk about. Then in equilibrium, we talk about extent of that reaction. We talk about when some reaction is at equilibrium, what happens, all these things. And in chemical kinetics, we talk about speed of the reaction. So these three chapters are directly connected with the variables of the reaction, right? In chemical kinetics, kinetics means something which we are talking about the speed, right? So we are basically going to talk about throughout the lecture, we are going to talk about the speed of the reaction, that is rate of reaction. We are going to talk about rate of reaction throughout this chapter, right? ROR, rate of reaction. Now, if you see, ma'am, what exactly the speed tells you. So see, some person will be very slow, someone will be very fast, someone will be moderate, right? Similarly, you have reactions. Some reactions are very fast, they will just occur in the blink of eye, right? Some reactions are moderate, not so fast, not so slow. But some reactions are very slow, right? So I'll give you some examples in our daily life, right? If you talk about daily life examples, can you see what is the work of preservatives? Why we add preservatives, right? What do they do, right? In simple terms, in chemical kinetics term, we can directly say that whenever we add any preservative into any pickle, anything you add, right? Anything you buy from, like you have frozen also nowadays, anything you purchase that has preservatives. That's why the shelf life is more. Reason is because the rate of decomposition is slowed when you add preservatives into it. That means it lower down all the preservatives that you see in juices, in cold drinks, in breads, in biscuits, everywhere around. We are just occupied with full with the preservatives all around us, right? So now they basically decrease the rate of decomposition, right? So they slow, the rate of decomposition is slowed. That's why our food is saved, right? Now, you must have also seen bread, right? Bread, some students, they love sandwiches, right? So, if you see bread, you can't keep it outside, right? You can't keep it outside. You have to keep it in the freezer. Fridge, you have to, refrigerator, you have to keep it in. Reason being, why? Same thing, that is decomposition, right? What happens? The bread, when it is outside, right, in the heat conditions, the rate of reaction is more, right? So as the temperature cools down, the rate of reaction lowers. That's why what we have seen that in when you have hot summer day, right, the temperature, outside temperature is very high, right? You need to keep everything in fridge, right? You can't keep things outside of, like outside of your fridge, that will decompose, right? But when you talk about winters, when you have temperature, let's say 3 degree, 4 degree, 5 degree, or in cold countries, right, where the temperature is very low, in those countries they don't need to keep everything in the fridge, but we need to keep it. Why? Because we have that kind of climate where, because of the temperature, rate of reaction increases, so it increases the rate of reaction when it is kept outside, right? So that's why it is not recommendable, right? Next is, how many of you have gone to dentist? How many of you eat a lot of chocolates and they have to go to dentist, cavities and all that? How many of you? Yes, Vinod, this is basically the first class. So I'll start from the basics. We'll go to the advanced level. Don't worry about that. Right? By seeing your video, thank you, ma'am. I got good marks in electrochemistry. That's great, Jyoti. And after chemical kinetics, we are going to start with electrochemistry only, right? So that will be a great thing. Why I didn't start with electrochemistry now only? Because I wanted that those students who have no idea about redox reactions, right? I'll teach redox reactions in class 11. Soon I'll teach, right? So what will happen that students who don't know anything about redox reaction, they can watch redox reaction in class 11, 6 p.m. class. and then they can also make a sync with electrochemistry, right? Okay, yes. Me, ma'am, me, only 2 students who have like cavity or have been to a dentist. Others are good students. What? Like no cavity, never went to any dentist, right, ma'am? We always brush our teeth day and night. No cavity. Even I have cavities. Yeah, what the big deal? Now everyone has. What we have done? We have eaten a lot of chocolates when we were kids, right? So dentists, they apply some layer on your cavity, right? Now what the dentist advises you to drink or to eat anything which is cold. They don't advise you after cavity or any treatment, root canal treatment, right? After any treatment you go, what they will advise you always is you have to eat something which is cold. You have to eat something which is like ice creams are advisable, right? Or like cold milk is advisable, right? Not, you can't eat like hot things. You can't eat dosa after that. Not possible, right? Why you can't eat dosa after that? Because what will happen, that layer, right? That layer need to be strengthened up in your teeth. For that, what they do, they all, so we want the rate of reaction will increase when you have cold layer on that. So that's why it will get layered up on your teeth, right? That is the reason, right? It is advisable to eat something cold after your dentist appointment, right? So all of these things are nothing but rate of reactions, everything around us, right? Now, if you talk about some explosive reactions, right? So many explosive reactions we have, like if you have seen on Diwali, right? On any good festival, what we have, we burn crackers, right? Which is definitely not good for the environment, but still people do it. So what are all these things? That is explosive reactions that is happening. It's not like firstly you will have a matchstick and you will light up the bomb. After 10 minutes, the bomb will be like, ha. No. Within nanoseconds, the bomb will be like, right? Why so? Because that is a very fast reaction, right? Some reactions are very slow. It's not like, for example, you are like drinking some cold drink, right? You're drinking cold drink. Very fast reaction will occur in your brain or in your nose, right? You will have that effervescence very fast, right? So all these things are fast reactions, right? Now, if you talk about carbon dating, right? You must have gone through carbon dating, right? Historians, what they do, right? Why I'm trying to relate it more to real life so that you can understand why we are studying this. Why chemists actually study rate of reaction, why this is such an important chapter. Because the rate of reactions, if you see carbon dating, if you want, why historians, how they know our ancestors, like how they used to be, right? All these theories that are there, like what happened 4,000 years back. Why? Because when they dig up everything, like inside the earth, like not inside the earth, like dig up everything, right? As down as they can go, what they find, different bones or different sculptures, all these things. From carbon dating, they understand that what exactly, they calculate the rate, like how much time it would have taken to decompose this particular thing to this amount, right? For example, they found out some bones, right? So they will see that this bone is at this particular condition, this bone may be of this year old, right? How? From rate of reaction. So everything, like all these historians, they are using is rate of reactions, right? So it is everywhere around us, from your daily life to the professional, like everywhere you will see the rate of reactions. That is the importance of rate of reactions, why we are studying this. Now let's understand this term, rate of reaction. That means speed of the reaction. But here one thing we know, that speed is equals to distance by time, right? Rate is always divided by time. So here what we are doing, we are talking about decomposition. We are talking about disappearance, appearance. So that's why the speed will be, the speed of the reaction, the rate of the reaction can be defined as change in concentration, because here distances are changing. When you are moving, your distance is changing, right? That's why it is divided by time. But when we are talking about a reaction, reaction is not like moving in a road or something. Reaction is concentration is changing, right? So that's why we will compare this with the change in concentration. So you can write it down. Rate of reaction is equals to change in concentration divided by time taken here. Divided by time taken. That is going to be your rate of reaction, right? That's how you calculate the rate of reaction. Now, students, let us see by taking ratio between C12 and C14. Very good, Gokul, very good, awesome. Right? So that is your rate of reaction. Now, we know that in a reaction, two things are happening. What are the two things? When reaction is proceeding, right? Reactant is getting consumed, right? Reactant is decreasing, but product is getting formed here. So can I say that whenever a reaction is moving on, we can say that the reactant is decreasing, product is increasing. In the same way, can we write it in the form of reactant and product? Rate of decrease in concentration of any of the reactants. When there is decrease in concentration of reactant and increase in concentration of the products. Okay, that is decrease in concentration of reactants because reactants are getting consumed, products are getting formed, so that's why there is increase in concentration of reactant, right? Now, understand one more thing here. So, I am talking about two pictures here, right? One I am talking about is decrease in concentration, other I am talking about is increase in concentration, right? One is reactant side. In reactant side, what is happening? Decrease in concentration. This is the product side. What is happening here? Increase in concentration, right? Decrease in concentration, increase in concentration is happening here. Now, one thing, 3-4 things I am going to tell you that are very, very important for you, right? After that, we are going to solve previous year question, JEE Mains, JEE Advanced, everything we are going to solve. But for that, 2-3 concepts should be like clear in your head, okay? First is, when I am talking about decrease in concentration, the rate of reaction will be negative, okay? Whenever I am talking about increase in concentration, rate of reaction will be positive, right? Okay, this rate of reaction will be negative, this rate of reaction will be positive. Now, why? Now the question is, ma'am, why? Why, ma'am, when reactant is decreasing, it is disappearing, you are saying it's negative. When the product is appearing, you are saying it's positive. What is the reason behind that? Let's find that out. Okay, let's find that out. What is the reason behind that? See, I am taking one random example here. Okay, so let's take an example that you have A to B, right? This reaction is going on. Now, here you have to tell me, when I am talking about, let's say here the concentration was the A naught, this is A naught, this is AT, this is B naught, this is BT. Okay, understood? Now see one thing. Here concentration is getting decreased. Which one will be greater? A naught will be greater because concentration is getting decreased. Here which one will be greater? Product is getting formed here. Concentration will be increased here. That means BT will be greater here. Can I write BT will be greater than B naught? Right? Simply I can write BT will be greater than P naught. Now, if I write down the rate of reactions here, what I told you, rate of reaction is change in concentration with respect to time, right? Now, I'm just writing here rate of reaction, change in concentration with respect to A, I am writing this is AT minus A naught, final minus initial by time T minus 0. Let's see here time is 0, here time is T, right? In this case, it will be BT minus B naught. divided by t minus 0. Now, if you see, if this is greater, then this overall will be positive. This overall will be positive, right? This overall will be positive considering this situation, which are always going to be this situation only when we are talking about decomposition, right? Most of the cases, this is the situation unless and until, right, your reactant is getting formed and your product is getting decomposed. Very rare situation. That also I'll tell you that when we will start doing the more of chemical kinetics lecture, I'll tell you that. But for now, ET minus E naught, tell me, will that be negative or positive? Will that be negative or positive? ET minus A naught. E naught is greater. Will that be negative or positive? Will that be negative or will that be positive? That will be negative. No, this is greater. So that will be negative, right? Now, tell me one thing. Can speed be negative? Can speed be negative? Ma'am, yes, I am not talking, you're talking about velocity. And simply in chemistry, we talk about only speed. No direction, nothing we are talking about, right? So, can speed be negative? No, speed cannot. Velocity is negative. Velocity is directional. Speed is not directional. So, speed cannot be expressed in negative. That's why we have to add a minus here because this is also minus to make the overall positive, right? If you want to make this overall positive, this negative should be there. So always understand, this is negative, this whole term is negative, negative will become positive. This is positive, that's why here you have positive only. Because speed can never be negative. Rate of reaction can never be negative, right? Rate of reaction will be always in the positive terms. That's why we always put, simply you can say whenever reactant is decreasing, rate of reaction will be negative, right? This will be positive. I am not saying rate of reaction. See, understand one thing. I am not saying rate of reaction is negative. If I put this negative and the decrement is like this, 7 minus, let's say, reactant in the initial stage you have concentration is 4, right? Or let's say in the initial stage the concentration was 4, final stage it was 7. So 7 minus 4, right? Wait a minute, opposite I am writing. In the initial stage it would be 7, final it will be 4 because reactant is decreasing, divided by, let's see, we are taking 3 as the time, right? If I don't put negative here, right, this will be 5, 6, 7, 3 by 3. It will be a negative number. It will be minus 1. Overall, it should not be minus 1. So that's why I'll put negative here, and answer will be 1. Okay. I am saying in the formula, you have to put negative. In the formula, answer will always be positive, whether we talk about reactant or product, right? I am saying that in the formula, you have to put negative in case of reactants, and in case of products, you will always put positive. If this point is clear to everybody, then let me know in the chat box if this point is clear to all of you or not. Is that point clear to all of you or not? Okay, Priyanshu. Great. Yes, ma'am, that is clear. Okay, perfect. So now let us talk about the next thing. Next thing is we have two things. One is the rate of reaction, simple rate of reaction I am talking about, right? Three things we have, okay? Three things we have. One is rate of reaction, or I'll just directly write rate of reactions. Two things we have here, right? Okay. One is rate of reaction. Other is rate of disappearance or appearance, right? Two things we have. Either I am talking about rate of disappearance appearance, or I am talking about rate of reaction simply, right? Now, if you talk about rate of reaction, next point, very, very important point. If you talk about simple rate of reaction, in that case, you should be clear that it should be divided by stoichiometry. Stoichiometry. I'll tell you what, right? And in case of disappearance appearance, not be divided by disappearance or appearance right? It should be divided by disappearance appearance. It should not be divided by disappearance. What I have written should be divided by stoichiometry. I'm so sorry, right? It should not be divided by stoichiometry. I just zoned out for a minute, right? So it should be divided by stoichiometry, right? Okay. Now let us see what do you mean by this, ma'am. Okay. Let's see that. For example, I have a reaction. This is the stoichiometry. This is the stoichiometry, the number, the digit before that formula. That is the stoichiometry, right? Now, whenever I have to write the rate of reaction, I'll tell you what is instantaneous, what is not. I'll tell you that. Don't worry about that. Just firstly, don't focus on this D or this is delta. What is this D or what is delta, that I'll tell you, right? For now, just understand one thing, whether it's D or whether it's delta doesn't matter to us, right? I am telling you when you have to divide by stoichiometry, when you don't have to divide by stoichiometry, right? If you see this here, this is DA, this is a reactant. Reactant will always have negative. So that's why what you will see, negative here, negative here. Product will never have, product side will never have negative. So positive here, here also you have positive, right? Now, this rate of overall reaction is reactant is dA by dt. So D capital A by dt, right? Then divided by the stoichiometry, that is A, equals to, this is dB by dt divided by stoichiometry. Then you have dC by dt divided by stoichiometry. Then you have dd by dt divided by stoichiometry, right? Now it doesn't matter if even if you have delta here, then also it will be same. Here it will be delta A by delta T equals to minus 1 by B. This is delta B by delta T equals to positive 1 by C. Delta C by delta T equals to positive 1 by D. Delta D by delta T. Okay? Same thing. Understand? Understood, everybody? Is that clear? Now, let us see, but ma'am, what is the big deal here? I'll tell you what is the big deal. Okay, let's say you have a question where the same question, if I write, right? If I write down the same question here, right? I'll just, wait a minute. Okay, what I'll do here, I'll just write down the same thing, right? But right now, I am writing the rate of appearance or disappearance, okay? So same thing I am going to write here. That is AA plus BB give rise to CC plus DD, right? Now here I am writing the rate of disappearance and appearance both, right? So first thing is what I will do, firstly I will write the rate of disappearance, right, or appearance. I will write the rate of disappearance of two things is there. Rate of disappearance of A, right? Then there is rate of disappearance of B. In rate of disappearance, when reactant is getting disappeared, So always there is going to be negative in the formula, negative, negative. This is dA by dt, no division by stoichiometry. This is dB by dt, no division by stoichiometry. You can also write it as delta A by delta T. You can also write it as delta B by delta T, right? So the difference is, whenever I am talking about simple rate of reaction, in that case I am dividing it by the stoichiometry. But when I am writing about the rate of disappearance, or if you want to write about the rate of appearance also, so here we'll be writing rate of appearance of C, or rate of appearance of D. Appearance of D. Now, who will tell me rate of appearance and disappearance? Future, education, Thala, Thalpa, Priyanshu. Who will tell me? Let us see who is going to tell me this. So, if you see this here, right, here what it is going to be, because it is getting produced, right? So, it is appearing. So, it will be positive. This will be dC by dt. This will be d capital D by dt, or in delta form you can write it as delta C by delta T, and this can be written as delta D by delta T. So what we learned till here, two things. One is, whenever we are talking about reactant disappearance, in that case rate of reaction in the formula is negative. In product side it is positive. Whenever we are talking about rate of reaction, in that case simple rate of reaction, in that case we'll have to divide it by the stoichiometry. But whenever we talk about rate of disappearance or rate of appearance, we will never divide it by the stoichiometry, right? Okay, now let's see some questions based on that. Now the next question is, ma'am, what is instantaneous rate? Ma'am, what is like small, you can say small difference or large difference, right? So there are two things. One is D, other is delta, right? So this is when you have small change. When we are talking about small change. This is when we are talking about large change. Large change. When there is large change in steps, then we talk about delta. When we are talking about small changes, instantaneous change, right? That is called instantaneous change. That is called small d. And mostly you will see small d only, because we are going to talk about small changes only. And this thing is only called instantaneous. Instantaneous. Okay, that is called instantaneous rate. Yes, everybody, at a particular instant and very, very small steps, we are dividing it. I'll also show you with the help of diagram here, right? For example, this is the graph here. What you will see, this is the instantaneous. I am talking about, let's say, instantaneous rate at 600 seconds. So I am telling you that at this instant, you have to tell me what is the rate of the reaction. At this instant, that means very small change you have to see here. At this particular instant, what is the rate of reaction, right? But when I talk about delta, in that case, we have large change. Let's say I'm talking about from this to this, you need to tell me what is the rate of the reaction. Let's say from this point to this point, what is the rate of your, what is the speed of your car, right? For example, you are going through this road, right? It's a very zigzag road. You're going here, right? Okay. So you're moving here, moving here, moving here, moving here, moving here. Now, if you see that if you at this particular instant, right, your friend said that, okay, what's the speed at this point? That is called instantaneous rate. But what is the average that is given in your speedometer of the car? That is called the delta, large distance. That means we are understanding that from this to this point, from this A to B point, we want to know what is the rate between these 2 points. That is called delta. Okay, that is called as delta, right? Okay, students. Now, if you see this, in this case, can you see what is happening? as time is increasing, concentration is decreasing. Time increases, concentration decreases. That means we are talking about reactant site, right? That's why it is written here, concentration of reactant. But whenever time is increasing, in this case, time is increasing, but concentration is increasing as well. So that is your product, because product concentration increases with the time. Okay, right? DPP will be provided to you, right? Solution DPP is already ready, but for that, I also need to see that you guys do your homework, right? So I want to see in the previous lecture how many of you do your homework, and even in today's lecture, if you like, I see 10 to 15 comments of the students who have done their homework, I would be very happy to share the DPP of solution with you. For that, you also need to put some efforts, right? Okay? Yes, everybody? Sure. Now, we are going to solve the questions, because physical chemistry is nothing without question practice. You can't just go through like this concept, I know, I'll do this in the exam. No, you have to do questions, right? So first we will start from the basic questions, then we'll start with the previous year questions, right? Okay. Okay, everybody. So, let's see this. Now, what you have here is derive the relationship between rate of reaction, rate of disappearance, X and Y, and rate of formation, that is appearance of X2, Y3, right? So this is what you have to see here, right? Okay, everybody, let us see very interesting questions. Today, though, very interesting question. You will find it interesting. They are basically chemical kinetics is interesting, okay? Derive the relationship between rate of reaction. So first you have to tell me what is the rate of reaction. See, whenever you have to see the rate of reaction, rate of formation of X2, Y3 is given to you. Rate of disappearance of X and Y is given to you. Okay. And appearance of this. Okay. Simple. Rate of reaction is what, everybody tell me. What is the rate of reaction? Shabash, everyone. Rate of reaction is equals to disappearance of X, that is minus D. Now I'll always talk D, small d, because mostly we're talking about instantaneous rate only. So I'm writing small d. Small d X by dt, but here you have to divide it by stoichiometry. So I'll write it as minus 1 by 2 dx by dt is equals to minus 1 by 3 dy by dt, because 3 is the stoichiometry here, is equals to, this is the product side, that will be positive, 1, the stoichiometry is 1 here, so 1 divided by 1 is 1 only. So dx2y3 divided by dt. Okay, so that is going to be the answer. Now everybody, tell me one thing, out of this, what is the rate of disappearance? Rate of disappearance is nothing but minus dx by dt. This is rate of disappearance of y. This is rate of appearance of x to y3, because there is no stoichiometry involved in that case. So can I write this, that rate of reaction is equals to 1 by 2 rate of disappearance of x is equals to 1 by 3 rate of disappearance of y is equals to rate of appearance of x to y3, right? Can I say this here, everybody? Can I write it here? Okay. Yes, everybody. Is that clear what we have here? Rate of reaction is this. We can directly write it down, but we know that this is rate of disappearance of y, because in appearance, we don't have any stoichiometry here. Right? Okay. Now, I'll simply write down a formula for you here. Always remember, rate of reaction is equals to 1 by stoichiometry rate of appearance or disappearance of reactant or product. This is a general statement that I have given you here, right? So that this can ease your like calculations in the exam, so that easily you can answer these things, right? So if you see, rate of reaction is nothing but 1 by stoichiometry, rate of disappearance, 1 by stoichiometry, rate of disappearance, 1 by stoichiometry, that is 1 only, rate of appearance. So directly we have this formula that you should definitely know for your, like if you want to like do answers in a good pace, right? Okay, that is clear. Now moving towards the next thing, that is rate of chemical reaction, the units, right? Now we are going to talk about the units, students. So if you talk about the units here, unit is concentration, time, right? But is that the unit? Don't worry. First thing is what you should remember, the units of rate of reaction. It is always concentration divided by time. Concentration is expressed in 3 terms, right? I am not talking about rate law. We have not started it till, right? So concentration is nothing but it is expressed in atmospheric also. It is expressed in bar also. It is expressed in Pascal also if we are talking about gases. Or concentration is expressed in molarity, mole. That's why we can also say mole per second here, right? So it is basically, if we talk about simple concentration, we express it in mole, right? So it is the mole per liter, right? Or we can also express for gases atmospheric, bar, Pascal per second, per hour, per minute. Anything can be there for time, right? So that's why we have written it per time. That is time inverse. Directly we have written it there, right? Okay. Now let's talk about the next question here, everybody. The question is, gaseous hypothetical chemical equation 2A give rise to 4B plus C is carries out in a closed vessel. It is carried out in a closed vessel. The concentration of B is found to be this. In 10 seconds, the rate of appearance of B is what? Right. So there is a hypothetical chemical reaction, that is this, right? The concentration of B is found to increase by this. That is the concentration, right? Mole per liter, molarity, concentration, right? In 10 seconds. Now, this, wait a minute, either I should write it here capital M or I can write it here mole per liter. So I'll write it here mole per liter per second. Okay. Now, if you see this here, this is the concentration change in 10 seconds. This is the time, right? This is the time. Concentration of B is found to increase. That means we can say this is the rate of appearance of B you have to write. Okay. So rate of reaction will be equals to concentration of change in B is 5 into 10 raised per minus 3. Time is 10 seconds. And can you see this here? B is the product. That means appearance. So it will be positive here. So it will be positive here. Right? And the units are, and the stoichiometry is 4. So it will be 5 by 4. So we can write it as 5 by 4 into 10 raised per minus 4. Right? Okay. So that is going to be there. And now next thing is, this is your rate of reaction. Right? Wait a minute. Found to increase by this in 10 seconds, rate of appearance. Wait a minute. Carried out in a vessel. The concentration of B is found to increase by this. Concentration change is this. You don't even need to actually need to find the rate of reaction here. You don't even need to find this here. This so I found out the rate of reaction, na? But you don't need to find that here because they are asking you the rate of appearance directly. So rate of appearance is what? Rate of appearance is simple. Rate of appearance is minus delta B or positive delta B by delta T. So delta B is 5 into 10 raised per minus 3, right? Divided by 10, right? It is going to be 5 into 10 raised to power minus 4, and that is going to be the answer, right? For rate of reaction also, I told you, just divide it by 1 by 4, you will get the rate of reaction, right? From there, you can also calculate A, C, whatever you want to calculate, right? But now they have just asking you the rate of appearance here, so directly you can write down that appearance will come out to be A is the correct answer here, right? Okay. Chalo. Next question is, rate of formation of nitric acid in the following reaction is this. Reaction is given to you. Rate of formation of nitric acid. Nitric acid is this. Rate of formation means which thing is given to you? dNO by dt. Rate of appearance means appearance is given to you. That means appearance is always positive. So it is given to be 3.6 into 10 raised to power minus 3. That is given to be 3 into 10 raised to power minus 3. Now students, find the rate of disappearance of oxygen. Oxygen they are asking you to calculate. See, very simple. Rate of reaction is equal to, we have to equate this and this. These two things we are focusing on. Rate of reaction in terms of O2 is minus 1 by 5 dO2 by dt. Why? Because in rate of reaction you divide by stoichiometry and this is decreasing, so there will be minus here. Is equals to positive of, because this is appearing, 1 by 4 dNO by dt, right? Now we know that if you solve this, what they are asking is disappearance of oxygen. That means they are asking you this thing, minus dO by dt, disappearance of oxygen. So can I write disappearance, you can just write it here, disappearance of oxygen is equals to, this 5 will jump here, this will be 5 by 4 dNO by dt. What is dNO by dt? That is 3.6 into 10 raised to power minus 3, and you can easily solve this and you will get your answer here, right? Okay students, is that clear? How do you find your answer here? How do you find your answer here? If that is not clear, you can always let me know in the chat box if that is not clear to you, right? Okay, that's how easily you can calculate it, right? Now next question, let us see. Next question is, you have 2 of H2O2 give rise to 2 H2O plus O2. Rate of formation of O2 is given to you, right? What is rate of formation of H2O? What is rate of disappearance of H2O? So simple thing is, this is there, right? And what is given to us? So simple. Rate of formation of O2. O2 is getting formed. It's not like O2 will always have minus dO by dt, right? Here it is getting formed. It is in the product side. So here we will write dO2 by dt is given to you, that is 48 gram per minute. Okay. Concentration is given in mass, that is gram per minute. Okay, perfect. We will also give the answer also in gram per minute, right? Rate of formation of H2O. See, rate of reaction will be equals to, simple thing, in terms of H2O2 it will be minus 1 by 2 d of H2O2 by dt is equals to, in terms of H2 it will be positive of 1 by 2 dH2O by dt is equals to, in terms of this it will be positive of 1, that's why it will be directly written as d of O2 by dt, d of O2 by dt, okay, d or O2 by dt. Now if you see this here, what is they are asking? The rate of formation. Rate of formation of H2O is nothing but they are asking you this thing, right? Rate of disappearance of H2O2 is nothing but this thing, and you know this thing. What you know is d of this thing. You have to equate this, right? You just have to equate this, right? D of, you can directly write that dH2 by dt, that is rate of disappearance of H2O2 is equals to, disappearance will be equals to 1 by 2 disappearance is equals to dO2 by dt. So disappearance will be equals to this multiplied by 2. because this 2 will come to the numerator side, so it will be 2 into 48, right? Then what about appearance of H2? What about appearance of H2? That will be this 2 multiplied by this will be your appearance of H2. So that will be 2 into 48 again, and that is going to be your answer here. Right? Okay, very good. Both are 96 gram per meter. Right? Okay, students. So that is your answer. So that was about the first concept of chemical kinetics, that is rate of reaction, appearance, disappearance. Then you have simple like positive, negative, like that. They can mix up and ask you the questions regarding that, right? Second concept that we have here is factors affecting rate of chemical reaction, that we are going to study throughout the chemical kinetics chapter, right? So I'll give you the pointers here, what we are going to study, and then we are going to see the questions on that. First thing is we will study about concentration, that on adding the concentration, right? On diluting, on adding the water, or on increasing the concentration, on decreasing the concentration, what happens? And for this, we will study rate law, right? So rate law is an expression, like you have rate. We will say that this is directly proportional to A, this is B. Now, this rate law is going to define whether here you will have 1, here you will have 2, here you will have 3, here you will have 1. What will be exactly the situation here? Rate law basically gives you rate of reaction is equals to rate constant. This case that this we will study in detail, don't worry. Rate constant, this is the this is the rate law constant. This is, let's say, A, reactant is B. Now, this will be raised to power X, this will be raised to power Y. This X and Y may or may not be stoichiometry. They may or may not be your stoichiometries, right? And the addition of these two things and the addition of X plus Y is equals to order of the reaction, right? Where this case called the rate law, or you can say just write it down, rate constant. This is called rate of reaction, and this A and B is the concentration. So how in different, see, X plus Y can have different number. X plus Y can be 1, 2, 3, 4. According to that, you will divide this chapter into first order reaction, second order reaction, third order reaction, and we'll study all of them in detail. So the concentration dependency is told by rate law and rate law expression. That is, rate is equals to rate constant, A raised to power X, B raised to power Y, where X and Y can be the stoichiometry. For example, you have the reaction that is AA plus BB give rise to CC. Now, this is what we are saying, that this X can be A, this X can be B. It's not always true that X will always be A or Y will always be B, right? So it's not mandatory. It can be, it cannot be. That's why we simply write it as that X plus Y, the addition is called the order of the reaction, right? Okay. Yes. No, it's not a one shot. Rate law is the expression in which rate reaction is given in terms of mole concentration of reactant, with each term raised to some power, which may or may not be same as stoichiometry of the reactant species in a balanced equation, right? Okay, that is called the rate law, which is going to tell us the dependency, and based on X plus Y, we call it as order, right? Now this order, right, can be 1, 2, 3. I'll call it as n. N is equals to 1, n is equals to 2. Sorry, n can also be equals to 0, n can also be equals to 1, n can also be equals to 2, 3, and so on, right? Based on it, you have, this is your first order reaction, which is very important. Then you have second order, this is zero order reaction, this is first order reaction. This is second order reaction, right? Third order reaction also we will see, right? But mostly we will study zero order and first order reaction in detail, right? These two orders you will study in more detail, right? Second dependency is the temperature. Now on the temperature, how the rate of reaction, generally it increases, right? Generally I am saying, generally increases. But we will also study that how it increases, right? We'll study some graphs related to that in our chemical kinetics chapter, right? This is just, I'm giving you an overview. The third condition is, factor is nature of reactant and product, right? Reactants, that means they want to get reacted or not. Product is feasible or not. If product is feasible, the rate of reaction will be high. If product is not feasible, you have some anti-aromatic product, then the rate of reaction will be very slow, right? If the product is stable, rate of reaction will be fast. So based on reactant and product also, rate of reaction depends, right? Then there is catalyst. This also we will study in detail, activation energy, graphs, everything. That how when you have any catalyst, now catalysts also are of two types, right? There is positive catalyst, there is negative catalyst. There is negative catalyst. Positive catalyst increases the rate of reaction. Negative catalyst decreases the rate of reaction. Like we have preservatives, right? Preservatives are positive catalyst or negative catalyst, guys, right? But don't worry, we are going to study molecularity, order, everything in a different lecture, right? So we will go with our own pace. Don't worry about that, right? So positive. So when we talk about preservatives, rate of reaction is slowed down. So that is a negative catalyst. Positive catalyst are which increases the rate of reaction, that you will study in organic chemistry, hydrogenation, nickel, platinum. All these are positive catalysts that increases the rate of the reaction. Okay. Now, fifth one is your surface area. Now tell me one thing. You have sugar crystals and you have powdered sugar, which will easily be mixed in the solution, which will easily react. Powdered sugar, right? So whenever we have two things, you have powdered chemical or you have cubes of chemical or crystals of chemical, powdered will always react faster. React faster because surface area increases. That is the reason powdered sugar or any chemical, right, that will react faster, right? So that is the thing, powdered, right? So now let's just talk about some questions, guys. Let us see if you're able to answer them or not. Let's see if you're able to answer them or not. First is, under the given experiment, increase in concentration of reactant leads to rate of chemical, increase to the rate of chemical reaction. Under the given experiment, increase in concentration of reactant leads to rate of chemical reaction decreasing, increasing, fluctuating, unaltered. If you increase the reactants, what will happen, right? In most of the cases, what will happen? When you add the concentration, when the reactant is added there, right, what will happen, guys? Rate of chemical reaction will increase or decrease. See, first thing is, it entirely depends upon whether you have zero order reaction. If you have zero order reaction, that is not at all dependent, right? Then it will have no change. If you have first order reaction, it will increase. You have second order reaction, it will increase exponentially. You have third order reaction, it will increase more exponentially. So in any ways, it will not decrease, it will not fluctuate, it will can be unaltered or it can be increasing depending upon the reaction. So my idea is, because here they have not given any reaction here, so both of them we can say right? But if I specify here that it is a zero order reaction, then the answer would be unaltered. If it is a first order reaction, second order reaction, then the answer would be increasing. Right? Okay, depends. Zero order or first order, that depends. Right? Here it is B written, but it can be D also. Right? Next is, you have a chemical reaction. For a reaction, rate of change of concentration for hydrogen is this. Rate of change of ammonia is what? Directly we will study this. Rate of reaction, we know that rate of change of concentration of ammonia. See, we have to compare this. Rate of change of concentration of hydrogen is this, okay? Rate of change of concentration of ammonia. See, simple is, you can just directly write here, rate of reaction is equals to minus 1 by 3, or you can just directly write 1 by 3 rate of change of H2. H2 is given to be this. So can I write it this? This is minus, this is given to be minus 0.3 into 10 raised power minus 4, right? Is equals to, ammonia is, change of concentration of ammonia is 1 by 2, that is in positive. So here you can write d of NH3 by dt, and you can give the answer as 0.3 multiplied by 10 raised power minus 4. This is 3 multiplied by 2, and that will be your dNH3 by dt. Can we answer this directly? But I have just directly applied it. Rate of reaction is 1 by stoichiometry. Right? Directly I have applied it, right? So it is going to be 1 by stoichiometry of hydrogen minus of dH2 by dt. Minus dH2 by dt is given to rate of change of concentration. That means this is minus dH2 by dt is already given to you. Right? So this is what I have written here. Right? And that is what we have the answer. We can finally get it. Right? Okay? Right, everybody? You can see this answer will be 0.2 into 10 raised power minus 4. So A is going to be the correct answer here, right? Okay. Next question is now we have some previous year questions right from this topic, very small topic we have questions. So you can see this, and I am taking out questions from the previous like 2-3 years back only. JEE means 2025. For a reaction, this reaction is given to you in a constant volume container. No product were present initially, right? Here he is saying that no product was present initially, zero product was there. Okay, wait a minute, guys. I think. So I'll just use this spec. For a reaction, just give me a minute. Even with specs, it's not. So let me try. For a reaction, N2O5 give rise to 2NO2 and half of H2 in a constant volume, right? Oof, what a misery. Chalo, no worry. For a reaction, this in a constant volume container, no products were present initially. The final pressure of the system and 50% of the reactions get completed. So basically, initially there was no product, right? So if we can see, initially I see there is no product. So I have written it as 0 and like 0, right? Initially at time 0, you have pressure as P0. And after time, this is stoichiometry. So P0 minus stoichiometry into X. This is stoichiometry multiplied by X. This is stoichiometry multiplied by X will be formed. Right? Now what he is saying that the final pressure of the system is 50% of the 50% when the reaction gets completed. So that means P0, it is the initial, is equals to final pressure is 50, that is half of P0 minus this plus 2x plus x by 2, that is going to be P0, that is P0 by 2. This is plus x by 2 plus x by 4. Because this is going to be x by 2, this is x by 4, right? Isn't it? This, if you take the LCM as 4, so it will be 3x by 4. 3x by 4. Isn't it? Yes. Right? So, if you see this here, this is the total pressure that you have. Right? Total pressure is nothing but that is, wait a minute, the final pressure of the system they are saying, no. At constant volume, no product were present initially. The final pressure of the system when 50% of the reaction is completed. They say it's actually not that of a question of chemical equilibrium, but still, chalo, this I would say this is more of a question of chemical equilibrium rather than this. The final pressure of the system when 50% of the reaction is completed. 50% of the reaction is completed, right? By this, you can find out the value of x here. The final pressure system when 50% will be. Acha, no. They are not saying the final pressure is this. The final pressure is this only. The final pressure is this only. They are saying when 50% of the reaction is completed. That means it is when half-life period is achieved, that means 50% of the reaction is completed. That means this P, this full has become P naught by 2. That means we can say that when P naught minus X is equals to P naught by 2, that is X is equals to P naught by 2. Right? When half of the reaction is completed. That means P naught by 2, we have subtracted it from here, right? That means we can say that X is equals to P naught by 2. Now you put the value, this is P naught by 2, this is P naught by 2, this is also P naught by 2. Now you add it, so answer will be P naught by 2 plus P naught by 4. So answer will be, this is 4, this is 2 P naught plus 4 P naught plus P. It will be 4, 5, 6, 7, 7 P naught by 4. Yes, the answer will be this as the correct answer. Okay, right? Okay, yes. So that's it. Now let's see the next question here. That is, rate law for a reaction between A and B is given by this. Right? There is some rate law. We don't know what is this Nm. All we know is N plus M is equals to order of the reaction. This is we know from rate law equation. If concentration of A is doubled and concentration of B is half, right? A concentration we are doubling. A concentration is doubled, right? B concentration is half, right? That is this thing, right? Now, can we say this will become K? This will become 2 raised to power N, A raised to power N. This is 1 by 2 M. This is B raised to power N. If you see this K, AN and this B, K, AN and this B, all of this is nothing but this is the old rate. This is the new rate. So new rate is equals to 2 raised to power N 1 by 2 M, that we can also write it as 2 raised to power minus M, and this is the old rate. So new rate is equals to 2 raised to power N minus M of old rate. So it will be 2 raised to power N minus M of the old rate. So answer will be B is your correct answer. Wait a minute, they are saying what is the value of R2 by R1? We have taken it by R dash. So if I take this as R2, if I take this as R2, this is your R2, this is your R2, this is your R1. So it will be R2 by R1 is equals to 2 raised to power N minus M. Right? So answer will be B is the correct answer here. Not C, B is going to be the correct answer. Okay? Okay, guys. Right? Sure. Now let us see the next question here. For a reaction is given to you, rate of formation of B is said to be 0. Then the concentration of B is given by. Okay. Rate of formation of B is said to be 0. I think this we are not like, this is K1, this is K2, this is basically they are telling you about rate constants here, right? rate of formation of B is said to be 0, right? Then the concentration of B. Rate of formation of B is nothing. This is rate law. This is K1. This is concentration of B, right? So they are saying rate of formation of B is said to be 0. That means dB by dt is equals to 0. Rate of formation of this is 0. The concentration is given by, actually this is what you will not be able to do today, right? This we will do in the later part because we have not studied about this in detail till now, right? We have not studied about this in detail. So we are definitely not going to go through that, right? Okay. Now, because in the next lecture I'll teach you in detail about other concepts as well. Then you can like understand that question. Consider the elementary reaction. Elementary reaction is one-step reaction, okay? If the volume of the reaction mixture is suddenly reduced to 1 by 3 of the initial volume, the reaction rate will become, now this is again 2025, if the volume of the reaction mixture, now they are saying, is reduced to this, right? So let's say, what is the volume? Let's say 1 by 3 of, let's say initial volume is this. If the volume of the reaction mixture is suddenly, it is 1 by 3 of V naught, right? The reaction rate will become X times the original rate, right? Okay. Beta, this is also out of your scope. No benefit of doing this today, right? We have not studied about like order of the reaction, so there is no benefit of doing that. I'll give you a trick on that. In that ways, you can easily solve pressure, volume, whatever is given to you. But for that, I have to firstly teach you the order of the reaction in terms of if concentration double, triple, like how to find the order of the reaction in the form of table, when hints on concentrations are given to you, when the hints on reaction rate being double or triple is given to you. In the table, the practical data is given to you, how to find the order. In that particular lecture, I'll pick up these questions because that will be more beneficial for you, right? Okay. Yes, everybody. Sure. Now, this is going to be your homework, students. Today was a very chill pill session, right? Very easy topic was because it was the first session. We are going to move towards the complexity, right? Rate of reaction, I have given you just a hint of rate of reaction. From that, we are going to study in detail about first order, second order, third order reaction, and then we are going to jump towards the find the order of the reaction, then catalyst, activation energy, all of that. Right, every single topic of this particular chapter is very, very interesting for you. And for that, I want all of you to write down the homework, right? Take a screenshot and give me answer for the homework. The first homework, right? Then you have why is negative sign added before the rate of reaction in terms of disappearance. This also I want to know from all of you. If you have actually understood the concept, then answer me these two questions right in detail. Right? And guys, this is our Vedantu JEE English Telegram channel. You can scan it and you will be landed to our Telegram page. Subscribe to it because we take the session from Monday to Saturday, 6 p.m. and 8 p.m. for your JEE classes, for your JEE exam, right? And students, I want all of you to do the homework, right? I want all of you to like the session, share this as much as possible, subscribe to the channel because this is what is beneficial, right? 124 and what likes, what, okay, I'll just see the votes here. I'll see that how many likes you have actually given, right? You will see that how students like they, ditch us. How many votes you can see? 134 votes, right? How many likes? 55 likes. Can you see, right? So this is what you want us to do. We promise you something and then we don't deliver you that. We don't do that, right? So you should also, you're not also not supposed to do that, right? So yes. And one more thing, students, here is our Sigma JEE batch. Click on here. The classes have already started, right? And what we are actually doing in this batch is we are not only taking the session just in the live classes, we are taking the session, but also full discipline is there. Doubt sessions are being taken in the classes. Then there is Tattva modules are provided to you. These QR cards are provided to you, as you can see over here. These kind of QR cards are provided to you. Modules are provided to you. You are provided with the DPPs, you are provided with the extra questions, right, to solve. You're provided with like DPP generator as well. You can generate your own DPPs as much as possible. All these things are there in the Sigma batch. You have your mock test after every 15 days, analysis, full thing is done in the batch itself, right? So everything is provided, and you can also, like, if you like missed some classes, then you can watch it in the recorded version, right, replay version, but also you can ask your doubts even in the replay version, right? So that is the best part of this course. You can see it is right now available at 3,999, which is the discounted price, right? And all the features I have mentioned you here, this is for 12th and the dropper students. And guys, that's it for today. I want all of you, right, to be there in the batch, because very disciplined study is going there in the batch, right? Okay. Yes. Okay, then I'll be waiting for your homework in the comment section, and let us see how many of you actually do your homework. Let us see that. How many of you are sincere enough to do your homework, right? Okay. Okay then, bye-bye. Take care. See you all in the next class. Bye-bye. Good night. Take care.